Good morning children, this is Latha. Welcome to class 7 IIT physics class. So children, what we are doing, we are discussing the Newton's second law of motion. Is it no? In the previous class we discussed about the Newton's second law of motion, and in today's class we are going to discuss some sums based on Newton's second law of motion. I hope you are doing well in the house. You are seeing the videos completely. Once again I want to tell you children, you have to watch the video classes till end, minimum 2 to 3 times. Then only you can understand the concept. Not only that, the reading content also you have to read 2 to 3 times completely. Okay, and you have to do the worksheets. Okay, so today we are going to start some sums on Newton's second law of motion. So let's start. Children, the mathematical form of Newton's second law of motion we already studied. Mathematical form is what? Force is equal to mass into acceleration. Is it no? So whenever we apply force on any body, if it is in rest or motion, you apply force on that body, compulsory its velocity will change. Is it? Whether its velocity can increase or decrease. So velocity compulsory will change. If the velocity of the body will change, then its momentum will change, because momentum is equal to what? Product of mass and velocity. So velocity of the body will change, then momentum will change. Then rate of change of momentum is equal to the or directly proportional to the force applied on the body. Okay, so from that we got the mathematical form of second law of motion, that is force equal to mass into acceleration. Clear? So keeping in this one in the mind, we will start now the question. First question, see children, what is the first question? What force is required to produce an acceleration of 2 meter per second square in a body of mass 0.8 kg. Okay children, so acceleration is 2 meter per second square and mass of the body is 0.8 kg. There is a body, okay, its mass is how much? 0.8 kg. How much force is required to produce the acceleration of 2 meter per second square in a body? I hope you understood the question children. There is a body of mass 0.8 kg. You applied force. As you applied the force, body accelerates. How much accelerates? 2 meter per second square. So how much force, okay, required to produce the acceleration 2 meter per second square in a body? This is a question. Very simple question. We are starting from a simple question. So now we will do. See, first we will write what is given in the question. That one first you have to mention. Then after, according to the given, we have to see whether it is directly we will use the formula or anything else we have to find out. Okay, so mass is given 0.8 kg, acceleration is given 2 meter per second square. So mass and acceleration both is given. You have to find force which is producing acceleration 2 meter per second square. So we have direct formula, force is equal to mass into acceleration. Mass is 0.8 kg into acceleration is 2 meter per second square. 0.8 into 2, 1.6 kilogram meter per second square. So how much force? 1.6 kilogram meter per second square, that is Newton. Is it? Newton, 1 Newton is how much? 1 Newton is kilogram, 1 kilogram meter per second square. Okay, so how much force is required to produce the acceleration of 2 meter per second square in a body of 0.8 kg mass? 1.6 Newton. Clear children? I hope you understood. Please note down this, take out your notes, give the heading, today's date, class, chapter, Newton's laws of motion. Then subtopic is what? Newton's second law of motion. Sums on Newton's second law of motion. And write down The first question, once again, when you are writing, okay, you have to pause the video, because we can't focus the paper for a long time, it will make the video again lengthy. That's why you have to pause the video, write the notes, and after writing only again continue the video. Okay, so now we will go for the second question. Now children, see the second question. First we will analyze the second question. A ball of mass 10 gram. There is a ball. Okay, there is a ball. What is the mass of the ball? 10 grams. Is initially moving with a velocity of 50 meter per second. On applying a constant force on ball for 2 seconds, it acquires a velocity of 70 meter per second. Calculate. So initially moving with a velocity of 50 meter per second. A ball whose mass is 10 grams. Initially it is moving with a velocity 50 meter per second, means what is this? This is called initial velocity of the body. 50 meter per second is what? Initial velocity of the body. Now on applying a constant force is applied on the ball for how much time? 2 seconds. Okay, a constant force is applied on the ball for 2 seconds, and of course if force is applied on the ball for 2 seconds, its velocity will increase. So before it was moving with 50 meter per second, now it is moving with 70 meter per second. Clear children? Before also I explained you, whenever a body is moving or in rest, when you will apply force, its velocity can increase or decrease. There are some circumstances when the velocity will decrease. Okay, we can't say every time velocity will increase. Sometimes velocity will decrease also. So there is a change in velocity. As velocity changes, momentum will change, because momentum is equal to what? Mass into velocity. So if velocity will change, compulsory momentum will change. Okay, now so now what we have to find out? We have to find out first initial momentum of the ball. Before going to find, first what I said children, you have to write down whenever you do any sums. Okay, mathematical sum or numerical, physics numerical, first what is given in the question you have to analyze and you have to write down first. After writing only you have to start calculating. Clear? So you can see mass is given 10 grams. What is the mass of the ball? 10 grams. So this one is in CGS unit. This one we will convert into SI unit. So what is the SI unit of mass? Kilogram. So gram to kilogram we will convert. So how to convert gram to kilogram? Divide by 1000. Is it now? 1 kilogram is equal to 1000 grams. Then 1 gram is equal to 1 by 1000 kilogram. So 10 grams is equal to 10 by 1000 kilogram. Have you understood? 1 kilogram equal to 1000 gram. Then 1 gram is equal to 1 by 1000 kilogram. Then 10 grams is equal to 10 by 1000 kilogram. Clear children? So that is 10 by 1000, that is 0.01 kilogram. Now initial velocity is what? 50 meter per second. For how much time force is applied on the body? 2 seconds. And what is the final velocity of the body? 70 meter per second. Clear children? These all things are given in the question. Now we will start calculating. So first you have to find initial momentum of ball. Initially what was the momentum of the ball? So momentum, we know momentum is equal to mass into velocity. Now initial momentum equal to mass into initial velocity. Remember children, mass will not change. Mass is a constant quantity. Got it? Mass is a constant quantity. If you will apply force on a body, velocity will change, momentum will change, but mass will not change, because mass is a constant quantity. Okay, So here initial momentum equal to mass into initial velocity. Okay, so mass into initial velocity, mass 0.01 kilogram into initial velocity is what? 50 meter per second. Already we had written 50 meter per second. So 0.01, that is 1 by 100 into 50. So 51 ja, 52 ja, that is 1 by 2, that is 0.5. So 0.5 kilogram meter per second is the initial momentum of the body. Very simple, children. Please write down first the question. Second question. Over, children. Now next is second one is final momentum of the ball. Okay, so final momentum same as it is momentum mass into velocity. Now final momentum mass into final velocity. So mass into final velocity. Mass is how much? 0.01 kilogram into final velocity. Final velocity how much, children? We have written already 70 meter per second. After applying force, a constant force on the body for 2 seconds, velocity of the body changed, and the body which was moving with 50 meter per second, now it is moving with 70 meter per second. So final velocity of the body is 70 meter per second. So once again 0.01 means 1 by 100 into 70. Okay, zeros cancel. 7 by 10, that is 0.7. So 0.7 kilogram meter per second is the final momentum of the ball. Please note down this. Once again, pause the video, write down, and after writing, continue the video. Now we will go for the next question. Next question is, see children, next third point we have to find out rate of change of momentum. Children, one thing I want to tell you, two things are there. First is change in momentum and second is rate of change of momentum. What is the difference in both? Change, whenever change we find, we are finding final minus initial, is it? That is change. So change of momentum, when you have to find, what you will find? Final momentum minus initial momentum. If you will find, that is change of momentum, a change in momentum. But when you have to find rate of change of momentum, means how the body is changing its momentum with the time interval, that is what? Rate of change of momentum. How the momentum of the body is changing with the time interval, that's why that is called rate of change of momentum. So whenever we find rate of change of momentum, we have to find final momentum minus initial momentum by time interval. Okay, so this is a difference you must know. Only change in momentum is final momentum minus initial momentum, but when you have to find rate of change of momentum, final momentum minus initial momentum by time interval will come. Okay children, I hope you understood well. Now we will see rate of change of momentum, that is final momentum minus initial momentum by time interval. Final momentum we got 0.7 kilogram meter per second and initial momentum is 0.5 kilogram meter per second, whole divided by time is what? 2 seconds. Force applied on the body for 2 seconds. So time is 2 seconds. So 0.7 minus 0.5, that is 0.2 by 2. 0.2 by 2 is 0.1. So 0.1 kilogram meter per second square, that is 1 Newton. Children, once again, Newton, 1 Newton is, its unit is equal to 1 kilogram meter per second square. So 0.1 kilogram meter per second square or 0.1 Newton. So understood now children, how much constant force applied on the body for 2 seconds? 0.1 Newton constant force applied on the body. Clear? You understood now? A ball whose mass is 10 grams moving with the velocity of 50 meter per second, and whenever a force is applied, constant force applied on a body for 2 seconds, then its velocity changed to 70 meter per second. How much constant force is applied? That is 0.1 Newton force applied on the body. Next point is you have to find acceleration. Before this, please note down this one. Third one. Fourth is acceleration. So what is acceleration? Rate of change of velocity. Is it? Acceleration is what? Rate of change of velocity. How the velocity of the body changes with the time interval. That is called rate of change of velocity with the time interval is known as acceleration. That is final velocity minus initial velocity by time. Okay. Final velocity 70 meter per second. Initial velocity 50 meter per second by how much time? 2 seconds. 70 minus 50, 20 by 2, 10 meter per second square. That is acceleration produced in the body, 10 meter per second square. Now next is force. Okay, so how much force applied on the body? So force applied on the body, we have the mathematical form of Newton's second law of motion, mass into acceleration. Mass is what? How much mass of the body? 0.01 kilogram into acceleration how much? 10 meter per second square. So 0.01 means 1 by 100 into 10. So how much? 0.1 kilogram meter per second square. That is 0.1 Newton. Now you see children. Third one. Rate of change of momentum. How much? 0.1 Newton. And when we calculated force also 0.1 Newton. So we got same. So according to Newton's second law of motion, force is equal to mass into acceleration. That is, force when applied on the body, velocity changes. And when the velocity changes, momentum changes. So rate of change of momentum directly proportional to the force applied on the body. So that's why force here how much? That much only rate of change of momentum. That is Newton's second law of motion. Clear children? Overwriting. Next we will go for the next question, third question. Question number 3. A cricket ball of mass 100 gram. There is a cricket ball. What is the mass of the ball? 100 gram. Moving with a speed of 30 meter per second is brought to rest by a player in 0.03 seconds. Okay, there is a cricket ball whose mass is given 100 gram. That ball is moving with a speed of 30 meter per second and it stopped by a player. So as it stopped, it came to rest. Its final velocity is 0. Is it? We already studied. Whenever a body starts from rest, initial velocity 0, and whenever a moving body comes to rest, its final velocity 0. So ball was moving with 30 meter per second. It came to rest by the player. So its final velocity is 0. In what time? 0.03 seconds. What you have to find here? Change in momentum and average force applied by the player. Okay, so force applied by the player, then only the ball stopped, came to rest. So how much force applied by the player? So once again, before calculating, first we have to write down what are the things given in the question. So first is mass of the ball 100 grams. That is a CGS unit, we have to convert into SI unit. So 100 by 1000, that is 0.1 kilograms. Then initial velocity 30 meter per second. Final velocity as the ball stopped, came to rest. So its final velocity is 0. Now time, in what time? 0.03 seconds. Clear children? Please note down this third question. So children, again you can see in the question, first you have to find change in momentum. Recently only I explained you change in momentum and rate of change of momentum. What is the difference? Okay, change in momentum, here you have to find, means you have to find final momentum minus initial momentum only. Is it? So first we will find initial momentum. Initial momentum means mass into initial velocity. Initial momentum, mass into velocity. Initial momentum, mass into initial velocity. Mass is 0.1 kilogram, initial velocity is 30 meter per second. So 0.1 into 30, 0.1 means 1 by 10. 1 by 10 into 30, of course 3, that is 3.0 kilogram meter per second. Final momentum, mass into final velocity. 0.1 kilogram into final velocity of the body. Body stopped, so its final velocity is 0. So anything multiplied by 0 is equal to 0. So final velocity is final momentum is 0. Okay, initial momentum 3 kilogram meter per second and final momentum is 0 kilogram meter per second. Okay. Now change in momentum. Whenever we find just change in momentum means final momentum minus initial momentum. But when we have to find rate of change of momentum, final momentum minus initial momentum by time interval. Clear? I think you are now very clear about this. So we have to find change in momentum, final momentum minus initial momentum. Final momentum is what, children? Final momentum we got 0. So 0 minus initial momentum 3. 0 minus 3, that is minus 3 kilogram meter per second. Clear? Now second bit, what you have to find? Average force applied by the plate to stop the ball. So average force, here force is equal to, we already studied now, according to second law of motion, rate of change of momentum is directly proportional to the force applied on the body. So force is equal to rate of change of momentum. So rate of change of momentum means what? Change in momentum by time interval. That is rate of change of momentum. So change in momentum by time interval. Change in momentum we got how much? Minus 3 kilogram meter per second. So minus 3 by time, how much time is taken? 0.03 seconds. So minus 3 by 0.03. Okay, here 3 0.03 means 3 and 2 decimal places, so 100 will go up, 3 cancel, it is minus 100 Newton. So how much force, average force applied by the player to stop the ball is 100 Newton. Here you children don't confuse about the minus sign, because force is not a negative. Here minus negative sign shows here that force applied in a direction opposite to the direction of motion of the ball. Suppose ball is moving this way, so force is applied in this way, opposite. For ball is moving this side, okay, then force is applied by the player from this side. Ball movement is this side, but player applied force this side, opposite direction of motion of ball. Then only ball stopped, no? Is it? So as the force applied from opposite direction, that's why this is a minus sign. Here minus sign, negative sign shows here that force applied in the direction opposite to the direction of motion of ball. That much only the sign shows here. So how much force applied? 100 Newton force applied. Which direction applied? Opposite direction of motion of ball. Clear children? Understood now? I hope you understood well. Okay. So please note down this second one, average force. Once again you have to pause video and then write down. After writing only again continue the video. Okay children. So in today's class we discussed some important sums based on Newton's second law of motion. I hope you understood. Like that, again sums you have to try, you must practice. Okay. So this is for today. Thanks for watching.